Hello guys, welcome. Today we will be starting about probability. Okay, so I am not going with very basic things. Let's start from base rule. Okay, so what it say? Probability of x small x given probability of y small y is equals to probability of x equals to x comma y equals to y probability y equals to y. Okay, so this is joint probability you can say, and this is the probability of y, capital Y, taking the value small y. So this we can also write in the form like probability x equals to small x times probability y equals to small y given x equals to small x by summation of all the x, probability of capital X taking small x, p y given capital Y equals to x dash. So this will result to probability of capital Y equals to small y. Okay, and this will result in joint probability. So uh, we all know this thing like expectation of x is given by summation of all x belongs to set of capital X, x, px. Okay, where px is the probability of x and this x belongs to the set capital X. X, this is for discrete, and for continuous we say x dx. Okay, and variance of x, which is given by the formula expectation of x minus mu whole square. Okay, what is mu? Mu is the mean of a random variable x. So this is represented by sigma square, which will be, if you uh, evaluate this equation, finally you will be getting x square minus mu square. Okay, or expectation of x square equals to mu sigma square plus mu square. This is important formula. So let's move to Bernoulli binomial distribution. This is for discrete. Okay, distribution. So suppose x can take any value from 0, 1, 2 up to n. Okay, where capital X is number of heads which can occur when we are tossing a coin for n number of times. So there is some probability that all of the tosses will give uh, the head, then there will be n heads, and if none of the tosses are giving head, then there will be 0 heads, right? So we write probability of k heads given, suppose probability of one of the head um, is theta, right? And this will be combined in theta k 1 minus theta n minus k, right? Where n k is n factorial by n minus k factorial and k factorial. Okay, but uh, so yeah, the mean will be here theta, and variance will be n times of 1 minus theta times theta. Okay, so variance we mainly say how much it is the spread. If the spread is too high or too less, the variance will uh, say how the spread is it is. Okay, and for Bernoulli's distribution, so suppose a single coin is tossed once, then uh, we can say that what is its expectation of getting head is given by theta indicator function x equals to 1 times 1 minus theta indicator function x equals to 0. Okay, so which is equals to theta when x equals to 1 and 1 minus theta when x equals to 0. So similarly we can define multinomial distribution also. So instead of only two states like head and tail, if there are k number of states, for example, if we are tossing a die and want to say what is the probability. Okay, so what we can do is like n theta, where x is a vector, right? Here is given by n x1 x2 up to xk, and this is pi j equals to 1 to k theta j xj. Okay, so what is this? This is nothing but n factorial by x1 factorial, x2 factorial, x3 factorial up to x k factorial. Okay, what is n? N is nothing but all the sum of x. Okay, so what is vector x? vector x, see here, vector s x can be sum of some number x1, x2, x3 up to xk, right? Yeah, xk, so that their sum, okay, should be equals to what? N. Yeah. So if suppose die is tossed for n number of times, right? And we want to see uh, 2 times x1 is appearing, 3 times x2 is appearing. Similarly, k times or m times xk is appearing, so that this all sums up to n. Then we will use this formula, okay, which is nothing but a generalized version of this formula mentioned above, like binomial distribution, what I have mentioned above. And finally, Poisson's distribution. Okay, what is this? This is given by uh, if the random variable x can take value 1, 0, 1, 2 up to infinite, and let us suppose there is one parameter lambda which is more than 0. Okay, so if x follows Poisson distribution with parameter lambda, then Poisson of a variable x given lambda is equals to nothing but e to the power minus lambda x by x factorial. This is the formula. Okay, now move to continuous distribution, and only one continuous distribution I will be discussing here. Rest all will be discussed in later classes. Okay, uh, this is Gaussian distribution. Gaussian distribution. Okay, so the formula of Gaussian distribution is given by x mu. So x is the variable, and mu and sigma square is the parameter. Mu is the mean, sigma square is the standard deviation, is given by 1 by under root 2 pi sigma e to the power minus x minus x minus mu whole square by 2 sigma square. Okay, this is the formula, and the precision of this Gaussian distribution is given by sigma, which is equals to lambda, which is equals to 1 by sigma square, centered on mu to the power 4. Okay, and for CDF, phi of this Gaussian distribution, phi with mu and sigma is given by half of 1 plus error function z by root 2. Okay, where What is z? Z is nothing but x minus mu by sigma. And what is error function of x? Error function of x is given by 2 by under root of pi 0 to x e to the power minus t square dt. Okay, so why we use this Gaussian distribution? Because uh, most of the distribution of the noise is Gaussian in nature. Okay, and the formula to represent this Gaussian distribution is also quite easy because it depends upon two parameters, and therefore it is widely used. Okay, let's meet in next video. Bye.